Good evening, class 11. Let's start. Today we are going to start a new chapter, equilibrium. Now, it's a general belief that when we mix reactants in exact proportion required and perform a chemical reaction, all reactants are converted into products with release or absorption of energy. However, it often happens that chemical reactions do not proceed to completion. By this we mean that reactants are not entirely converted to products. Instead, after some time, reactant concentration no longer change with time. The reaction system at this point consists of mixture of reactants and product. A chemical system in such a state is said to be in a state of chemical equilibrium. Chemical equilibrium is established when two opposing processes in a chemical reaction balance each other. So equilibrium is defined as a state of a process in which properties like temperature, pressure, concentration of the system do not show any change with passage of time. Let us consider a general reversible reaction which is given as this one: A plus B reversible C plus D, where A and B are my reactants and C and D are the products. So in the beginning, the concentration of reactants are large and those of the products are zero. Therefore, only forward reaction takes place. With passage of time, the concentration of reactants go on decreasing, so the rate of forward reaction also decreases. On the other hand, concentration of the products, which means C and D, goes on increasing and rate of backward reaction also increases. Ultimately, a stage is reached at which rate of forward reaction becomes exactly equal to the rate of the backward reaction, and concentration of the reactants and products becomes constant, and after that it does not change with time. So it is called a state of chemical equilibrium. So we have two graphs under this. One graph is concentration versus time and another one is the rate of the reaction versus time. Now when we are talking about concentration, then definitely we are talking about concentration of reactants and product with time. So here what's happening with progress of time or with the passage of time, concentration of the product increases. So this is my C, D, this is A and B, or I can just write it in general form, product, and this is my reactant. Okay, right? So this one is my equilibrium point. Okay, the point at which the concentration of both reactants and products starts becoming constant, that point is termed as the equilibrium point. So this is your plot of graph of concentration of the reactant versus time. With time, concentration of product increases and that of the reactant decreases with time. Okay. Now another one we have rate of the reaction versus time. So here what is happening? Rate of forward reaction decreases, backward reaction increases. So this is my backward reaction and this one is forward reaction. Okay, this one is my equilibrium state. These are the two graphical plots which basically defines the equilibrium. Okay, now next we have characteristics of equilibrium. Now equilibrium is always attained in case of a closed vessel. Equilibrium is dynamic in nature. Dynamic means after the attainment of equilibrium also the process goes on, but the concentration of the reactants and products will be maintained constant throughout, right? And rate of forward reaction is equal to the rate of the backward reaction. This is another feature. And the last feature is that when equilibrium is attained, then properties like temperature, then concentration, etc., that will also be constant. Okay, that will also not change, right? So these are the few characteristic features of equilibrium. Next, we move to the example of physical equilibrium. Example of physical equilibrium that we are going to discuss, that is liquid vapor equilibrium. Now this equilibrium is attained when rate of condensation is equal to the rate of evaporation. Now how is it happening? We'll be discussing the procedure. When liquid is kept in a closed vessel which is maintained at a given temperature using a thermostat. Since the liquid is being heated, the molecule at the surface undergo evaporation. As the vessel is closed, the gas molecules cannot escape. So it comes in contact with the liquid undergoing condensation. Right? So in this particular process, we have some terms. The terms are vapor pressure. The pressure which is exerted by the vapor which is in equilibrium with the liquid at a given temperature. And this vapor pressure property, it is attained only in case of liquid vapor equilibrium. Okay, there are certain factors that affect the vapor pressure. First one is nature of the liquid. Liquids with strong intermolecular force of attraction requires more time to attain the equilibrium. So rate of evaporation as well as rate of condensation will be lesser, thereby lowering the vapor pressure. In case of liquids with weaker force of attraction, equilibrium is easily attained, vapor pressure increases. Next factor is temperature. On increasing temperature, kinetic energy of liquid molecules increases, so they readily leave the surface forming vapor, which comes in contact with liquid to move to its initial state. Hence rate of evaporation is faster, equilibrium established in lesser time, so the vapor pressure is higher. Right? So that's it, class 11. Thank you.